Hello everyone. Today I am going to discuss about static electricity. What is static electricity? Static electricity is such kind of electricity which cannot moves from one place to another place in a body like electric current. We know that electric current or can move from one place to another place through wire, but static electricity cannot move from one place to another place in a body, confined in a body, and it is produced by friction by two different kinds of bodies, and it can be also produced by method of induction. And we know that there are two kind of charges. One is positive charge and another is negative charge. And we also know that a positive body can attract a negative body or vice versa, and a charged body can also attract a neutral body. But two positively charged body always repel with each other, and two negatively charged body also repel with each other. That means same kind of charge always repel each other, and different kinds of charge always attract each other. Now, Coulomb's gives us a theorem which tells us about the magnitude and direction of the force. Now, I am discussing about the Coulomb theory. Coulomb theorem. Let us consider 2 point charges Q1 and Q2. 2 point charges are separated by a distance r. We consider that these 2 point charges are similar type of charges. Okay, then the 2 point charges repel each other. Let Q1 and Q2 be the 2 point charges placed at a distance r in air or vacuum. If capital F be the magnitude of the force acts between the two given charges, then according to Coulomb's law or Coulomb's theorem, we can write the force magnitude of the force is directly proportional to the product of the charges. That means F directly proportional to Q1 and Q2, and F is inversely proportional to the square of the distance between them. That means F inversely proportional to 1 by r square. Therefore, F is directly proportional to Q1 Q2 by R square. Now we can introduce a constant term when we write an equal sign except proportional sign. So therefore F is equal to K into Q1 Q2 by R square, where K is a proportionality constant. Proportionality constant. Okay. Now I can erase the board. The value of the constant therefore is different in different measurement system. That means in CJ system the value of K is 1 when we place the two charges in air or vacuum. That means in CJ's system in air or vacuum, K is equal to 1. In SI system in air or vacuum, K is equal to 1 by 4 pi epsilon 0, where epsilon 0 is known as permittivity of air or vacuum. The value of 1 by 4 pi epsilon 0 is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. We know that the unit of force in SI system is Newton and the unit of charge in SI system is Coulomb. On the other hand, the unit of charge in CJ system is stat Coulomb. Okay. Now we are going to discuss about electric field and electric potential, but in future we write we write the Coulomb's theorem or electrostatics laws or formulae in SI system. It is more convenient and applicable in present time. Okay. From Coulomb's theorem, we can define unit charge. What is unit charge? Unit charge. From Coulomb's law, we know that F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Okay. Now let Q1 is equal to Q2 is equal to Q. R is equal to 1 meter. F is equal to 9 into 10 to the power 9 Newton. Then therefore we can write Q square in by 1 square into 9 into 10 to the power 9 is equal to 9 into 10 to the power 9. The 9 into 10 to the power 9, this term is the value of 1 by 4 pi epsilon 0. Therefore, we can write Q square is equal to 1. Therefore, Q is equal to plus minus 1. This is known as, or this charge is known as 1 Coulomb. Therefore, 1 Coulomb is the amount of charge when two similar type of charges are placed in air at a distance 1 meter apart, then the force between the two charges is 9 into 10 to the power 9 Newton. Okay, this gives Q is equal to plus minus 1 Coulomb. C stands for Coulomb. Now uh, we going to discuss about the vector form of Coulomb's theorem. Q1 and Q2 are two charges, and we already considered that the two charges are same kind of charge. That means either they are both positive or they are both negative. Then they repel with each other. If the force on Q2 due to the charge Q1 is F, then F acts from Q1 to Q because it is a repulsive force, and Q1 produces F force on Q. Okay, we consider that Q1 is placed at the origin O and Q2 is placed at a point P at a distance R from point O, and R is the position vector of point P with respect to the point O. Therefore, the direction of F and direction of R are same. That means F vector and R vector are at the same direction. Then we can write F vector is equal to magnitude of F vector into R cap, because unit vector of F and unit vector R are same. Since unit vector of F is equal to unit vector of R. Okay, cap stands for unit vector. Then we can write that F vector is equal to 1 by 4 pi epsilon 0 Q1 Q2 by mod of R whole square into R vector. Again, we know that r cap is equal to r vector by mod of r vector. Therefore, f vector is equal to 1 by 4 pi epsilon 0 q1 q2 by r vector q into r vector. This is the vector form of Coulomb's law. Again, we can write it in with respect to the Cartesian coordinate system. We can draw three mutually perpendicular axes OX, Y, and OZ. That let two points A and B. Position vector of A is R1 and position vector of B is R2 with respect to the origin O. The vector of AB is R. Then we can write then R vector is equal to R2 vector minus R1 vector. It comes from triangle's law vector addition. So therefore, we can write F is equal to 1 by 4 pi epsilon 0 q1 q2 by R2 minus R1 whole cube into R2 minus R1. This is the another form of Coulomb's law in vector form. Coulomb's law vector form. Okay. Now we can erase the board. Now I'm going to discuss about the definition of absolute permittivity of the medium and relative permittivity of the medium. What is the absolute permittivity of the medium? Of a medium. Absolute permittivity of a medium. If we place the two charges in any medium other than air or vacuum, then the Coulomb's law can be written in the form F is equal to 1 by 4 pi epsilon q1 q2 by r square, where epsilon is the absolute permittivity of that medium. Where epsilon is the absolute permittivity of a medium. Now, what is relative permittivity of the medium? Relative permittivity of the medium is denoted by epsilon r. Epsilon r can be written as epsilon r is equal to epsilon by epsilon 0. And obviously epsilon r has no unit or dimension. Okay. Value of epsilon r in air or vacuum is how much? 1. Because absolute permittivity of air or vacuum is also epsilon 0. Therefore, epsilon 0 and epsilon 0 cancel with each other and epsilon r is equal to 1. What is the unit of epsilon? Unit of epsilon is how much? Coulomb square per meter square per Newton. This is the unit of epsilon. Then what is the dimension of epsilon? Dimension of epsilon is Coulomb current I into T whole square meter length to the power minus 2 force M L T minus 2. This is equal to M L minus 1 T0 I. This is the dimension of epsilon. Okay. Next, I am going to discuss about the electric field. What is electric field? When we place a point charge Q, then this charge can create a field around itself. That means when another charge is brought near to Q, then it may repel or may attract the charge, second charge. That means this charge can create an electric field around itself. This is known as electric field. Then what is electric field strength? What is electric field strength? Let Q be a point charge placed at the point O. We also consider another point P at a distance R. if we place a unit positive test charge at the point P, then the charge Q repel repel or attract the unit test charge at the point P. Then the force experienced by the unit test charge is known as electric field at the point P due to the point charge Q. Okay. Now, what is test charge? Test charge is very small amount of charge whose dimension is very small, and the test charge cannot change or influence the electric field of the electric field created by the charge Q. Okay, that means the charge or magnitude of charge or influence of charge and influence of the plus unit charge or discharge is very small with negligible or very small or negligible with respect to Q. Then we can say that this is a discharge. Now the force experienced by unit positive charge is how much? Q into 1 by R square into 1 by 4 pi epsilon. When it is the experiment is conduct in air or vacuum, and this force can be denoted by capital E. Okay, this is known as electric field strength at that point P due to the point charge Q. Or in short, we can also say electric field at P due to the point charge Q. Clear? So therefore, we can write that E is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is equal to 1 by 4 pi epsilon 0 Q by R square. This is equal to the magnitude of field electric field at point P due to charge or point charge Q. Okay, the vector form of E can be written as E is equal to 1 by 4 pi epsilon 0 Q by R vector magnitude of R vector square into R cap, or E is equal to 1 by 4 pi epsilon 0 Q by R vector whole cube into R vector. Unit of the electric field is unit of electric field is Newton per Coulomb. Okay. Then what is the relation between electric field strength and force? relation between electric field and force. Now Q, the point charge Q is placed at O. Another point charge capital Q is placed at the point P. The distance between O and P is R, or the shortest distance between O and P is R. The force between Q and P is F is equal to 1 by 4 pi epsilon 0 Q into Q by R square. Okay, is equal to 1 by 4 pi epsilon 0 Q by R square into Q. Then we know that 1 by 4 pi epsilon 0 Q by R square is equal to electric field E. Therefore, F is equal to electric field into charge. So, therefore, force on a point charge is equal to electric field or electric field strength at the point into magnitude of the charge, magnitude of charge. So therefore we can write F vector is equal to E vector into Q. This is the relation between electric field and force. Now I am going to define about electric dipole and electric dipole moment. What is electric dipole? When two charges, when having same magnitude but opposite in nature, are separated by at a certain distance, then this system is known as electric dipole. That is, if minus q and plus q are 2 point charges are separated by a distance 2l, the distance between the 2 point charges are 2l, then this system is known as electric dipole. And electric dipole moment is defined as the product between the charge and the distance between them. That is electric dipole moment P is equal to 2ql, and the direction of electric dipole moment acts from negative charge to positive charge, and direction from A to B along A to B or along negative charge to positive charge. Okay. Unit of electric dipole moment is electric dipole moment is Coulomb meter. Coulomb meter. Now I am going to calculate about the magnitude and direction of electric field created or produced by an electric dipole at the point on the axis of that dipole. Let O be the midpoint of or middle point of AB and C be another point on AB or extended AB. The distance between O and C is R. Now we are going to find out the magnitude and direction of electric field at the point C produced due to the electric dipole AB. Therefore, we can consider a unit positive discharge at the point C plus 1 charge. Now, the minus Q charge attracts the plus 1 charge and plus Q charge repels plus 1 charge, unit positive charge. Therefore, electric field electric field at C at the point C due to minus Q charge is E1 is equal to 1 by 4 pi epsilon 0 into Q by the distance AC. AC means R plus L whole square and its direction along C to A because minus Q charge attracts plus 1 charge along direction along C to A. That means minus R cap. Minus R cap. Okay. Electric field at the point C due to plus Q charge is E2 is equal to 1 by 4 pi epsilon 0 Q by R minus L whole square R cap. Because the distance between B and C is R minus L, that is BC. Therefore, resultant electric field at the point C due to the electric dipole is E is equal to magnitude of E2 minus magnitude of E1 and its direction along r cap, because magnitude of E2 is greater than magnitude of E1. This is equal to 1 by 4 pi epsilon 0 q into r plus r minus l whole square minus of r plus l whole square r cap. This is equal to q by 4 pi epsilon 0 this is equal to q by 4 pi epsilon 0 r plus l whole square minus r minus l whole square by r minus l into r plus l whole square whole into r cap. This is equal to q by 4 pi epsilon 0 4 into r into l by r square minus l square whole square into r cap. Again, we know that electric dipole moment P is equal to 2ql. Therefore, 1 by 4 pi epsilon 0 2ql is replaced by P. Therefore, 2p into r square minus l square whole square into r. This is the electric field produced at the point due to at the point C due to the electric dipole. Okay, next topic. Electric field produced by the electric dipole moment at the point on the perpendicular bisector of that dipole. This minus q charge is placed for minus q a point charge is placed at the point A, and plus q another charge is placed at the point B. O be the midpoint of AB and 2L be the distance between A and B. OC is the perpendicular of AB. OC is perpendicular of AB. Now we are to find the electric field at the point C. OC is equal to R. We can join AC and BC. Electric field at the point C acts along A to C, and electric field at C due to the plus charge acts along B to C. This is E1 and this is E2. Let OC is equal to R, AC is equal to BC is equal to D. Now, electric field electric field at the point C due to minus Q charge is E1 is equal to 1 by 4 pi epsilon 0 Q by B square acts along A to C along C to A. C to A. Electric field at the point C due to plus Q charge is E is equal to 1 by 4 pi epsilon 0 Q by B square along B to C. Since magnitude of E1 is equal to magnitude of E2, therefore their resultant acts parallel to B O A. E be the resultant of E1 and E2. Let E be the resultant of E1 and E2. That means E is the resultant electric field at C. Okay. Therefore, we can consider that E is equal to E is equal to under root of E1 square plus E2 square plus 2 E1 E2 cos theta cos 2 theta. Okay. Now we can put the value of E1 and E2. Therefore 1 by 4 pi epsilon 0, where 2 theta is the angle between E1 and E2. 1 by 4 pi epsilon 0 q by d square whole root over of 2 plus 2 cos 2 theta. This is equal to 1 by 4 pi epsilon 0 q d square into 2 into 1 plus cos 2 theta is equal to 1 by 4 pi epsilon 0 q by square 2 into 1 plus cos 2 theta means 2 cos square theta. This is equal to 1 by 4 pi epsilon 0 q d square into 2 cos theta. Now we can write cos theta is equal to L by d. L by d, that is, this is theta, this is L, this is d. The hypotenuse base, this is theta. This equal to 1 by 4 pi epsilon 0 2 ql, this equal to p pi dq. Okay, and we also know that dq is equal to d is equal to under root of L square plus R square. So this is equal to 1 by 4 pi epsilon 0 p by L square plus R square whole to the power 3 by 2. And the direction of E is E is parallel to positive charge to negative charge, parallel to B to A. Okay. Now we are going to discuss about the electric field produced by the electric dipole at any point. Okay, that is AB are 2 points and Q minus Q1 and plus Q1 are 2 point charges. O be the midpoint between them and OL is the distance between them. Okay. Now C be any point and OC is equal to R and COB is equal to theta. Now find out the electric field at the point C due to electric dipole. If we know that the direction of electric dipole acts from negative point to positive point. That is, P acts from A to B. Now we can resolve the P vector into two mutually perpendicular components. That is, one is along R direction, P cos theta, and another is P sin theta perpendicular to R. Okay, that is, R is perpendicular to P sin theta and P cos theta is parallel to R. Now, the electric field at the point C due to the dipole P cos theta is equal to E R, and electric field at the point C produced due to P sin theta is E theta. Okay. Now electric field at C due to P cos theta is E R is equal to 1 by 4 pi epsilon 0 2p cos theta by RT, and electric field at C due to P sin theta is E theta is equal to 1 by 4 pi epsilon 0 P sin theta by RT. Here the P is the electric dipole moment of AB, and here P is the electric dipole moment of AB, and R is excessively greater than L. Therefore, we can neglect the value of L in the expression of ER and E theta. Since E theta and ER are mutually perpendicular direction, since ER perpendicular to E theta, therefore the resultant electric field at C is E is equal to under root of ER square plus E theta square. This gives E is equal to P by 4 pi epsilon 0 under root of 2 cos theta whole square plus sin square theta. Therefore, E is equal to 1 by 4 pi P by 1 by 4 pi epsilon 0 under root of 1 plus 3 cos square theta. Because we know that sin square theta plus cos square theta is equal to 1. If E makes an angle alpha with ER or R direction, then let alpha be the angle between E vector and ER vector, then tan alpha is equal to E theta by E R. This is equal to half into tan theta. Okay. Now, next topic is the torque acts on the electric dipole placed in an uniform electric field. We consider this is an uniform electric field, and uniform electric field is denoted by parallel lines of force. And electric lines of force is directed from positive charge to negative charge. Therefore, in the external electric field is directed from here left to right. Therefore, electric dipole, when an electric dipole is placed in the uniform electric field, then the minus q charge is moves towards the positive field, and plus charge plus q charge is plus q charge moves towards positive field. Theta be the angle between the electric field and the axis of the electric dipole. 2n is the distance between the two point charges, plus 2 and minus 2. Now force acts on plus q charge is F1 is equal to q into E, and force acts on the charge minus q is also F is equal to q into E. The magnitude of two forces are same, but they act in opposite direction. Therefore, they form a couple. We know that when two same charge, same forces, two forces having same magnitude acts on a body in different direction at the two different points, then they form a couple. Therefore, F1 and F2 form a couple. Force acts on each charge is q into, okay, is equal to magnitude of F1 is equal to magnitude of F2. Since F1 is equal to minus F2, therefore they form a couple. Therefore F1 and F2 form a couple. Okay. Therefore torque acts on the electric dipole is tau is equal to R cross F, where R is equal to 12. Magnitude of R is equal to 12. Where magnitude of R is equal to 12. Therefore, magnitude of torque R is equal to RF sin theta is equal to 2N into QE is equal to PE is equal to PE sin theta. Okay. In vector form, or tau is equal to P cross E. P vector cross E vector. This is the end of the topic.